Hi, everybody. This is Professor Monty, and welcome to Chapter 2 of Statistics. So what we're talking about in Section 2.1, variables and data, and I put up there a little diagram for you. A variable is just whatever we're looking at, whatever kind of information we're trying to get. So the variable could be what color's your car, how tall are you, what's your favorite animal. Anything like that is going to be the variable. And now variables, as you can see, are broken down into either qualitative data or quantitative data. Now, qualitative data, as the word implies, quality, this is anything, qualitative data, any information that's non-numeric. So I'm just going to jot it underneath it, non-numeric. So it's not a number. It's going to be a quality. So if we talk about the color of your car, that's a quality. Clearly, it's not a number. That's going to be qualitative data. If we talk about your favorite animal, again, that's a quality. Quantitative data comes from quantity, so that is numeric. So quantitative is numeric. So it's just numbers, if you'd rather just say number there. And it's broken down into two types of data, discrete data and continuous data. The big thing that you have to remember with discrete data is these are things we count. Not a very good you, is it? So discrete data, things we count. So if we're talking about, oh, how many sandwiches did I eat last week? Well, that's going to be discrete data. Or if I say, how many cars are parked in the parking lot? Again, discrete data, I can just count those. Continuous data, on the other hand, is something we measure. And so it can have any value from some lowest number to some highest number. So it's that we measure. Examples of continuous data would be time, would be distance, weight, height. So those are some examples of things that we would measure. So other things, obviously, if we're talking about volume or area, those are going to be things we measure. So that's continuous data. And the reason it's because there's some of tests and sometimes of displays, graphical displays, we can only do with qualitative data or we can only do with quantitative data. Furthermore, there's tests we can only do if it's discrete quantitative data, and other tests we can only do if it's continuous quantitative data. So it's important to get our feet wet here and to understand at the beginning what the differences is between these. Okay, so we've got a little bit of that idea right there. So we're going to go through that. Let me show you a picture. And I'm going to grab a picture out of my file, and we will go ahead and just paste that in real quickly. So let's go here, and we'll paste that in. Okay, so here's a problem out of the book. It's problem 2.6, as you can see. World's highest temperatures. Information provided by the World Meteorological, well, easy for me to say, Meteorological Association revealed the following data on the highest recorded temperature for each continent. And so they rank the continents, they say what the continent is, what place it was, in other words, the location, and then what the highest temperature was in Fahrenheit. And notice North America in Death Valley had the highest temperature ever recorded at 134 degrees. Antarctica, the highest temperature ever recorded in Antarctica was 59 degrees Fahrenheit. So not a very warm place to be. But the question that they're asking here is what type of data is in each of these columns. So in this first column, they're talking about the rank. Well, the rank, notice it's just numbers. Remember, well, let's start off. It's numbers, so is it qualitative or quantitative? It's a quantity, so obviously it is quantitative data. And do we measure the rank, or would we count and see, you know, which one's the highest, which one's the lowest? Rank is actually going to be discrete continuous data, because remember, If it's continuous, we'd measure it, and then we could get any number between a small and a large. There's no rank between 1 and 2. We can't say, oh, this continent was 1.768. So this first column right here, that's going to be discrete. And obviously it is quantitative. The next one, it's not numbers, so it has to be qualitative. So the continent that it was on was a quality, it's qualitative. Similarly, the place, again, non-numeric, so it's qualitative. And then the temperature, even though those are listed as whole numbers, they were just rounded off to the nearest whole number. We do know it's quantitative because it's a number. But since we measure the temperature, it is continuous. And so that's the idea. If it's a number, it's quantitative. If it's not, it's qualitative. If it's a number that we count, it's discrete. And if it's a number that we measure, it's continuous. So you'll see some problems on the homework to kind of get a better idea of that. But that's the idea between the different types of data that we have. Okay, now, amazingly enough, that's pretty much all of section 2.1. So let's go ahead and we'll go into the next section, 2.2, organizing qualitative data. So this is organizing qualitative data. 2.3 will be organizing quantitative data. So organizing, what are we going to do? Well, the first thing we're going to do is we're going to do what's called a frequency distribution. And the frequency just means how many times did we get this value in our sample or in our population, depending on what we're measuring. If we have all the data, remember in chapter 1, population's all the data possible for the group we're interested in, and sample is just what we took from that population. So we don't know if this is population or sample at this point. Whatever it is, how many of the people that we did talk to had this characteristic. Okay, so that's the frequency, is the number that had the characteristic. There's also, well, that's what the frequency is. The frequency distribution is just a listing of each category. It's an O. Along, oh gosh, along with its frequency. My writing leaves something to be desired, doesn't it? With its frequency. And remember, frequency just means the number of times that we see it. There's also relative frequency. And relative frequency has to do with how many times we see something versus the total. So relative frequency is just the frequency that something is divided by total number of whatever it was we were sampling. And so we'll see these as we do an example so that it will make more sense. We'll say observations here, if that helps. All right, so we'll do that. We've also got some ways to do this. Now, what we do is we can break this up, because remember, this is organizing qualitative data. So we can do the frequency distribution. I'll actually show you one of those. But we can also look at pictures. And so pictures, there's two types that we usually use for qualitative data. One is a pie chart, which I'm sure you've seen. And it's just portions of the whole. Portions of the, we'll say, entire circle. And so you've seen these before. We draw a circle and we may do this, and this is, blue, and this is green, and this is red, and we'd do something like that. And again, I'll do that in our example. And the other one is called a bar chart. And a bar chart, just as it sounds, I'm not even going to explain it. We'll just draw a picture of one. So say again, we had blue, green, and red, and maybe we had a bar up here and it was that high, and the green one wasn't quite as high, and then the red one was the highest one yet. So we'd have something like that. And one thing about a bar chart, the bars don't touch with qualitative data. And that's important because with quantitative data, we're going to see something that looks like a bar chart, but the bars touch. The reason they don't touch here is because the order doesn't matter. I could have done red, then blue, then green. I could have just switched up the order. It doesn't matter. But bars don't touch. And I will even go a little bit further and say with qualitative data. And the main reason they don't touch is because you can put them in any order you want to. Sometimes they put them from highest to lowest, but you don't need to. You can put them however you would like. So with that, what I'm going to do is I'm going to go to another example. What I'm going to do is we're going to see this and we're going to talk about, hey, you know what? How do I know what these things are you're talking about? Can you give me an example? And of course I can give you an example. So let's put a problem from the book right here. All right. So it says primetime broadcast shows. From the TV by the Numbers website, we obtained the networks for the top 20 primetime broadcast TV shows by total viewers in August 18th, 2013. All right, so here's what we're going to do. We're going to start with a frequency distribution. So frequency distribution. And there only needs to be two columns. One is going to be network, and the other is going to be the frequency. Now I'm going to put an extra one here that we wouldn't put in a formal one if we're publishing this for some sort of research or for your job. I'm going to put another column in here called tally, so I can just keep count of them. What I could do is I just could count all the CBS and put them in frequency. But if I didn't have a nice thing to look at here, sometimes we put in tally. And here's the idea. We would go, and I'm just going to do it the order that we see them in. CBS, NBC, ABC, Fox, and it looks like that's all we have. So I look at, let's go across the row. So I'm going to go CBS, there's one, NBC, there's one, NBC, there's another one. Those are my tallies. ABC, there's one, CBS, there's one, CBS, there's another one. CBS has three more. We'll make that a 5. One more for CBS. Fox has one. 1, 2, 3, 4 more CBS. 1, 2, 3, 4 more CBS. NBC, NBC, Fox, CBS, NBC, ABC. Let's see, they said there was 20. I have 11. I have 16, 17, 18, 19, 20. So it looks like I have them right. I'm assuming I put them in the right spot. So my frequency, I'd say, hey, there's 11 of these. There's 5 of these. There's 2 of these. And there's 2 of these. And now it makes it much easier to look and say, instead of just seeing the data and saying, wow, it looks like there's a lot of CBSs. And I can say, oh, there was 11 CBS. There was 5 NBC, 2 ABC, 2 Fox. I could even add these together and say, okay, you know, totally there's 20 of those. And then if I wanted to make it a relative frequency distribution, I would just add another column and we'd call it relative frequency. And with relative frequency, what I'm going to do is I'm just going to divide, for instance, the 11 divided by 20. And I wouldn't put that there. I'm just putting it there so you see in what I am doing. So let's see. That's going to be what? 0.55. Oops. Wow, that didn't work out well at all. And then I do 5 divided by 20. So it's 0.25. And then 2 divided by 20. I'm not going to write those down. It's going to be 0.10 and 0.10. And we know we do our math correctly, or we think we probably did, if when we add those up, we get to 1, which would be 100%. So let's see. Bring down add those two 5s, we get a 1, carry the 1, we get 6, 7, 8, 9, 10. So it's 1.00. Now, if you have a little rounding error, on these we shouldn't have any rounding errors because everything was 20, which is nice. We didn't have to round off any of our relative frequencies. But if it was a total of 17, and then we had to round to 2 decimal places or 3 decimal places or whatever, in your last digits, you may be off by 1, either too much or too little, and that's okay, but you shouldn't be off any more than that. So that, the way I have it written now is actually a relative frequency distribution. And in relative frequency, you can just put network and relative frequency if you want to. If you wanted to put those as percentages instead of decimals, you're welcome to do that. 55%, 25%, 10% and 10%, it's all good. But that's a frequency distribution or a relative frequency distribution, depending on how you want to look at it and which of those columns you're going to include. Okay, let's go to the other types of charts for this. I'm going to leave that up so I can see it. But if I do a pie chart, now if you wanted to do this technically, you'd take the 360 degrees in a circle and you'd break it up, you'd multiply it by 55% or by 0.55 and find out how many degrees that is. We don't need to do these by hand. The computer's always going to do these for us. But I wanted to just show you, hey, we can do this by hand. What does this look like? Okay, so let's go ahead and do that. We're going to get a pie chart. And 55% of it is CBS, so that's a little more than half. So if I went straight across, and I kept going straight across, it'd be 50%. It's a little more than that. So we're just, wow, I don't know where everything went. That's just horrible. Let's start this circle over. Okay, so let's get our circle. Again, put a dot in the middle. I'll go here, I'll go a little more than straight across, and this is going to be CBS. Let's see, in about 25%, that's a quarter, that'll be easy. Go straight down there, that's going to be NBC. And then half and half of what's remaining, these would each be 10%. I might have drawn that a little off, but we'll call this ABC and Fox. I'll go at an angle here so that I have a little more room. There we go. And I guess I could have drawn Fox along the bottom to see that a little bit better, but there's my pie chart. And it's a very visual way to easily say, oh, CBS was the majority, CBS was next, and ABC and Fox were about half and half. You can't exactly tell from my picture. My picture actually looks like ABC is a little more, which it's not, but that's a pie chart. And let's go to the next step. We'll do a bar chart, either based on frequency or relative frequency. It's your choice. They're going to look the same. I'm going to do it on frequency this time. So let's say bar chart. Remember, the bars do not touch since we're working with qualitative data. And so let's do this. We're going to, on the side, we're going to say frequency. On the bottom will be the network. So I'll just list them. And I'll list them in the order that I have them, even though it goes largest to smallest. It didn't need to. CBS, NBC, ABC, and Fox. All right, so frequency, notice our biggest one was 11, so let's go 5, 10. So a little more than 10, we've got 11, so I'm going to do a bar up that high, just above 10. That's going to be CBS. I like to darken my bar a little bit. NBC, we had 5. That's going to be up to that first tick mark I drew. Try to draw the bars the same width. ABC only had 2, so it's, if that's 5, it's 2/5 of the way up, so about 40%. So maybe about here. And Fox is the same height as that one. And there's our bar chart. again, very easy to see. CBS had the most, followed by NBC, and then ABC and Fox each had a little bit. 2 of the 20, so they each had 10% of the shows that were the most watched. Okay, so essentially that's the idea. There's 2.2 in a nutshell. That explains the things we want to see there. So now what I'm going to do is I'm going to go back here. We'll go into 2.3 and see this last section for this lecture. Okay, now 2.3, as you can see, organizing quantitative data. So when we list those, or when we organize it, there's 3 ways to do it, depending on what type of data we have. One is what we call single value. And so with these, an example I like to do in class is I'll go around the class and I'll ask students, how many kids are in your family? And so they'll say 1 kid, 2 kids, 3 kids, whatever it is. And when I break that up, I just break it up. Okay, how many people had 1 kid in their family? How many people had 2 kids? How many people had 3 kids? And that's just breaking it up by a single value. But another one would be what we call limit. And when we do limit grouping, should I say grouping here? When I do limit grouping, what happens is I use a bigger group. So I will do limit grouping with grades. And I will say, hopefully not how many people got 0 through 9, and then 10 through 19, 20 through 29. But if everybody passed the class, I would say, oh, how many, let's say we go down to 50. How many people got 50 to 59? How many people got 60 to 69? How many people got 70 to 79, etc., all the way up to 100? And that would be limit grouping. So if you got a B in the class, you know you were somewhere between 80 and 89. That would be limit grouping, because there's more than one number that goes in there. Ideally, you'd have the same number of possible values in each one. With grades, I can get 90 all the way to 100. So there's actually 11 different scores that can go in there, where the other ones, if I go 80 to 89, there's only 10 values. The 1 through 81 through 89 is 9 values, plus 80 itself gives you the 10th value. But including both the 90 and the 100 gives me 11 values. And that's okay in something like that. Ideally, you want with your limit grouping each group to have the same number of possible values in there. And then the last one we talk about, they call it cut point grouping. And cut point grouping is usually used when we have continuous data. So if I'm weighing out, I don't know, say I'm weighing out logs, and I may say, okay, any log that's between 0 and 10 pounds is going to go in this group, but 10 to 20 pounds is going to go in that group. Well, if I have something that's 10 pounds, which group do I put it in? Well, so I would say in that case, let's put all the logs from 0 to just less than 10 pounds. Will go in this first group. If it's 10 pounds to just less than 20 pounds, it'll go in the next group. And if it's from 20 to just less than 30 pounds, it'll go in the next group, etc. So with cut point grouping, it's usually continuous data, and I cut it off at some number. And I say, okay, it's anything up to but not including that number. And I'll show you a picture of that in just a minute. All right, so when do we use these? So now I'm going to grab a picture to talk about when we would actually use these groups. All right, so let's do this. Let's see. Oh, I know what I want to do. All right. So I'm going to grab this, and I've already grabbed it, and I'm going to put it here, and we'll see what that looks like. All right. So grouping methods, single value grouping, when do we use it? Well, we use with discrete data in which there are only a small number of distinct values. Limit grouping, when the data is expressed as whole numbers and there are too many distinct values to employ single value grouping. Okay, so I've got a bunch, like the example with the grades, all the C's all grouped together, B's all grouped together, etc. Now notice it could have been continuous data, but it's rounded off numbers. So in this case, if I did these logs and I did them to the nearest pound, and I'd say, okay, I'm just going to narrow it. This is a 10-pound log. This is an 11-pound log. Well, now I can do 0 through 9 go in the first group, and 10 through 19 go in the second group. Then I could use limit grouping, or I could do cut point grouping when the data is continuous and it's expressed as decimals. So that kind of explains it right there. Let me show you an example of where they actually do this to see if that helps you get an idea of it. All right, so here's my example. Let's put it right there. Okay, so this is another table out of the book, and it talks about, let's look at some ideas. Okay, number of TVs somebody has in their house, and they give you the frequency. Well, discrete data, and there's only a few different numbers, 0 through 6. There's 7 different possible numbers. So they give the frequency and the relative frequency, but notice the frequency is just how many people had 0 TVs, how many people had 1 TV, 2 TVs. So we can use single value grouping because it's discrete data. There's not too many of them. Now look at part B when it talks about days of maturity for some sort of a bond or something to give us money probably. I guess they say days to maturity for short-term investments. So when I look at that, it's from 30 all the way to 99 days. Too many. We don't want to list 30, 31, 32, all the way up to 99. So they do limit grouping. Oh, 30 to 39 in this group, 90 to 99 in the last group. And they give both the frequency. If they just gave the days to maturity and frequency, it's a frequency distribution. The way it's written, it's a relative frequency distribution. You don't have to have the middle frequency column if it's just a relative frequency distribution. So sometimes you'll just see, in this case, maybe days to maturity and relative frequency, and that'd be a relative frequency distribution. But notice they don't have tally in any of those because they didn't need that. And then the last one, they're talking about weights of 18 to 24-year-old males. Well, we know that weights are continuous. So in this time, notice if somebody's 140, we know where they go. They don't go in the 120 to under 140, they go in the 140 to under 160 group. And so that's an example of each of those. I wanted to show you that picture just so that you could get a good idea. Okay, and with that, when we think about it, we should be able to do an example of this type of thing and really kind of understand what's going on. So let me scroll this up a little bit. I'm going to paste that in there. And here's an example, 297. Now, the way the book numbers problems, the 2 in the front means it's chapter 2, and the 97 means it's the 97th problem in the chapter, not in the section. Because in the section, in section 2.1, the first problem in there will be 2.1, and then the second one will be 2.2. But if it goes, say, in chapter 2, section 1, say it goes up to problem 20, then the first problem in section 2 would be 2.21 because it's chapter 2, the 21st problem in the chapter. So this is the 97th problem in the chapter, not the 97th problem in the section. Okay, so women in the workforce. In an issue of Science, D. Normil reported on a study from a Japan Statistics Bureau of the 30 industrialized countries in the Organization for Economic Cooperation and Development, titled Japan Molds Workforce Goals for Women. Following are the percentages of women in scientific workforces for a sample of 17 countries. Construct a stem and leaf diagram for these percentages. Here's what I'm going to do. We've talked about the different types of ways we can group these things. What I'm going to do, now we're going to talk about the way we can display these graphically. And there's 3 basic ways we can display these. I'm going to do all 3. But before I do that, let's start with a frequency distribution. So let's do frequency distribution. And we have to decide which way we think it would be best in order to group these. Now, since these are percentages, it's not continuous because they're rounded off to the nearest. So I'm not going to use the last one. I'm not going to use cut point. And there's too many of them to use single value grouping. I don't want to start at the lowest one, which looks like 13, and list 13, 14, 15. Oh, I see it, 12. 12, 13, 14, 15, all the way up to the highest one, which looks like it's 44. I don't want to list every number. So let's break it down in the 10s, 20s, 30s, and 40s. So for my frequency distribution, I'm going to say the class, which is the same thing as calling it the group. Oftentimes they use the word class though, and frequency. And class, let's just do this. Let's erase that. Let's actually call it percentage of women. And there's more verbiage there, but so that it fits, I'm just going to narrow it down to that. So percentage of women in the frequency. And so we'll do this. And let's do the percentage. Let's go 10 to 19%, 20 to 29, 30 to 39, and 40 to 49. I didn't put a tally here, so this time let's just count them. So in the tens, let's see, there's the 12 and the 13. 1, 2, 3. I get 3. Remember, there's 17 total, so we'll add up at the end to make sure we got all 17. In the 20s, I see 1, 2, 3, 4, 5, 6, 7. In the 30s, I see 1, 2, 3, 4, 5. And in the 40s, I see 1, 2, just 2. All right, let's see. 7 and 3 is 10, and 7 is 17, which is what they told me. So we're good there. So I do have the right number. I can do a relative frequency if I wanted, 3 divided by 17, 7 divided by 17, etc. Don't want to. 17 is not going to come out as a nice number anyway. But let's do this. Here's going to be the 3 different ways that we can show these. The first one's a histogram. And a histogram is essentially a dot. Now, a bar chart, except this time the bars touch each other. And we'll talk about why once we draw it. So what I'm going to do is I'm going to draw my bars here. We'll say frequency again over here. And we'll do percentage of women down here. And often they'll just put the whole thing, 10 to 19. Sometimes they'll just put the lower bound. They'll say, oh, the 10s, and they put it on the left side. I like to show the whole thing, even though these are going to be awfully wide bars. 20 to 29, 30 to 39, and 40 to 49. All right, so 7's our biggest. So I'm going to go 1, 2, 3, 4, 5, 6, 7. And let's see, in the first group, we have 3. So let's go up to 3. I'm just going to put a dot there for now. Then I have a 7, which went all the way up to the top. And then I had a 5. So let's see, there's a 3, 4, 5 there. And a 2. All right, so let's just do bars like this. My 2 looks awfully small now, so we'll go up a little bit higher. But remember, the bars touch, so we're going to go in between each of these to draw our bars. Make 2 a little bit higher. And so now it looks like this. And if you think about why the bars touch, because there's nothing in between there. We didn't lose any gaps there. We can't change the order of the bars. We wouldn't want to put the 20s before the 10s. That wouldn't make any sense. Because when we look at this, we say, oh, it's going from lowest to highest. So the bars always touch with quantitative data. We'll go ahead and say that. Bars touch with, I have room here, quantitative data. All right, so there's a histogram. That's what a histogram looks like. There's also what they call a dot plot, which is essentially a histogram. except we just do dots. So it's going to look the same way. We're going to have frequency over here. Mine's kind of angled. And then we could do the same thing. We go 10 to 19, 20 to 29, etc. But what's nice about a dot plot, they're real easy to make. Because when you look at the numbers, you can just put a dot there. Oh, 26, there's a dot right here. 12, there's a dot here. 44, there's a dot here. 13, stack up the dot. 40, stack them up. 18, 39, 21. So I'm just putting the dot in whichever column the number would go in. 35 goes in the 30s. 27, of course, goes here. Make sure they're lined up. 34, 28, 34, 28. I sound like a broken record. 33, 29, 29. And notice the dot plot was really easy to make. We didn't even need the frequency distribution for that. We could just go from the raw data. But what it does for us is it gives us the same picture. We can easily see, oh yeah, the 20s are the highest stack. So it's the most frequent of the groups, followed by 30, followed by the 10s, followed by the 40s. So it's a real easy way, but it should have the same shape, of course, as the histogram. Now, I'm going to show you a stem and leaf diagram, which was what this question originally asked. And with a stem and leaf, here's what happens. A stem and leaf works really well with 2-digit numbers because what you do, the stem is on the left side. And so we've got the 10s, 20s, 30s, and 40s. I'm going to go 10s, 20s, 30s, and 40s. That's called the stem. And then on the right side, for instance, when I get the number 26, I just put a 6 here because I know it's 26. So I put it in the 20s row, but it's a 26. And then 12, I put the 2. So I just put the second digit as the leaf. So the stems are on the left, the leaves on the right. And notice the leaves are just the second digit. So I've got a 44, I've got a 13. Again, I just write the 3. 1, 3, 13. 40, 18, 39, 21, 35, 27, 34. Make sure those are lined up. 28, 33, 29, 29. And because now when I look, it's essentially either the dot plot or the histogram just turned on its side. And again, we can see, oh, the 20s are the most common. So we still get that same idea there. Looks like I lost one of my ones in the 30s. I think I only did one of the 34s. Yeah, I see that there's 2 34s up here. And I only have one of them. I was looking and I'm like, wait, I'm missing. So let's just put another 34. I think since I did that, because now I have 6, but I see there's 7. It was that 34, 28, 34, 28. I only did one of those. So I got the 34, I needed another 28. So now it ties into the rest of those. Now I've got the right number in each of those. Now, this is a stem and leaf. Do they call it a display or a diagram? Stem and leaf diagram. And what happens, it gives me that nice little picture that's a real easy way of doing essentially the histogram. What's nice about the stem and leaf, I didn't lose any of the data. If I look at the histogram, I know there were 7 numbers in the 20s, but I don't know what they were. Were they all 20s? Were they all 29s? Was there a mixture in there? I don't know. But if I look at the stem and leaf, I have all the numbers. I haven't lost any data, but I still get the picture. So that's one of the things that's good about the stem and leaf is you still have all your data. Now, sometimes on the right side, the leaves, they'll put them from smallest to largest. That's called an ordered stem and leaf. And I think in the homework, they make you put it in as an ordered stem and leaf. Because remember, if it's not in the computer, the way they program the answers, the computer's not going to recognize that you have the right answer. So if they ask you for a stem and leaf, I think they want it to be an ordered stem and leaf. So for instance, in the 40s, you'd have to put the 0 before the 4. And then obviously in the 2s and the 3s, you'd have to order those smallest to largest as well. But that's a stem and leaf. Sometimes if you have a lot of data, they'll do another stem and leaf, but they'll say 2 stems per line. So this is going to be another stem and leaf, but this time it's going to be with 2 stems per line. Stem and leaf. So this time what they're going to do, they're going to do 2 columns for the 10s, 2 columns for the 20s, 30s, and 40s. But what they're going to do, this first one is just going to be 10 through 14, because that's 5 different numbers that can go in there. There's the 1 through 4 plus the 0 is 5. In here, it's going to be 15 through 19. Again, there's 5 numbers that can go in there. And so just remember, if it's in the 5, it goes in the second one. So when I do this, I can look to the left. I said, oh, there was a 12 and a 13. There was an 18 that's going to go down here. With the 20s, let's see, there was a 26, a 21, 27, 28, 29, 29, 28. In the 30s, there was a 39. It goes in the second one. A 35 goes in the second one. 34 goes in the first one. 33 goes in the first one. 34 goes in the first one. And in the second one, both 4 and 0 go in the first one. Again, I didn't do it ordered. You may want to do it ordered, but either way, it's technically correct. Okay, so if you have a lot of data, you may want to break it down into 2 stems per line, or you may want to go 5 stems per line. And then the first stem would just have 0 and 1, the second stem 2 and 3, 4 and 5, etc. You want the number of stems to be divisible by 10 if you have 10 possible things going in each one of them, which we do. So breaking them down into just either 1 stem or 2 stems or 5 stems would pretty much be your only choices, since it has to be, the number has to be, it has to be a divisor of 10. So it has to divide into 10 evenly. Okay, so that's the end of what material we're going to cover in chapter 2. So next time, of course, we will go into the next chapter, which is chapter 3. We actually break that down into 2 different lessons. So we will do that next time. I hope this helped you out. If you liked it, click on the like button. That helps people find the video. Subscribe to my YouTube channel if you haven't done that already. And best of luck to you, and we will talk more later.